First of all, I know this is a radical equation. Radical equation is where the variable x is inside of a square root or cube root or any radical. Okay? Something about radical equations. So even if the question didn't say this, you must verify. So that sometimes you'll just say, it'll say solve this equation. You have to know with a radical equation that you must verify. There's a possibility that the answer you get is not true. But we're going to check. We're going to solve this out. Do we remember? Okay, so first of all, recognizing it as a radical equation, first thing, having a name for that's important. And how do we solve radical equations? This should trigger that you need to isolate the square root and then square. So what's going to happen a fair bit moving forward in math is a bunch of previous things that you've done are going to appear, and as soon as you see a radical equation, you're expected to be like, oh, I recognize it's a radical equation. How do I solve a radical equation? Well, I need to get rid of that square root. Makes sense that getting rid of the square root means squaring, but I first need to isolate that to make sure that it goes away when I square it. Then I remember that I must verify. So, I look at the equation. I have a square root. I need to isolate that square root, so I move my 4 over. This would allow me to square. Squaring a square root cancel each other out, leaving me with just 6 minus x. Squaring a binomial means x minus 4 times x minus 4. You're going to have to FOIL that out. So you're going to get x squared minus 8x plus 16. Everybody okay? I'll do it off to the side here. Are you okay with the outside and the inside happening all at once? That your outside is minus 4x, your inside is minus 4x. Together, that's going to combine to be minus 8x. So something that you would have probably showed a lot more work in, say, grade 9 and grade 10. Now in grade 11, it's like, it's okay if you just do that all together in your head and put the answer down. But I did do it off to the side there. Okay. So, we did the isolating of the square root and we squared. And as a result, we look at our result and we're like, oh, well now what do I have? Name it again. Now I have a quadratic. Equation. What did we use to solve quadratic equations? So just like when you recognize the radical equation that you need to isolate and square, we did that and oh, we ended up with a quadratic equation. What do we need to use to solve the quadratic equation? We need to use that zero product property. In other words, we need to make one side equal to 0. Personally, I like to keep whatever's squared positive. So you see your x squared is already positive on the right side. So I would move those things over to the other side, making this 0. That way my x squared stays positive, but to move this minus x over, you see you'd have to add x to both sides. Minus 8 plus 1 will now give me minus 7. And to move this 6 over to the other side, I'd have to subtract 6 from both sides, giving me plus 10. Once you've got one side equal to 0, we can now factor. If it's factorable, this would have to be x and x. That seems like it would work. Two numbers that give you 10, so that your outside and inside is a 7. 1 and 10, 5 and 2. What do you think? You see the 5 and the 2? Now, you need the outside and inside to make a minus 7. That would only work if you had a minus 5 and a minus 2. Does your last one still give you plus 10? Yes. And so now, our zero product property, we change this to a multiplication. And right there at the multiplication, I can split it and say, the zero product property says that if this is equal to 0, either the first one is 0, can you see that 5 would make the first one 0? Or the second one is 0. And because it started as a radical equation, I know the question said verify, but I'm going to write that we must verify this. Now we have two answers to verify, so let's just clarify here. First, I'm going to verify x equals 5. Set up my left side, draw my line, set up my right side, and we go back to the original equation. So we look right back to the beginning. My left side originally was the square root of 6 minus, I'm going to plug in x, which is 5, plus 4. My right side, I'll plug in 5 for the x. So I plug in 5 for x, and 6 minus 5 is the square root of 1. Square root of 1 is 1, 1 plus 4 is 5. We have verified x equals 5. I'll put a check mark under that one. Next, number 2, I'm going to verify x equals 2. Left side, draw a line, right side. I'd have the square root of 6 minus, insert 2, plus 4, and on the other side, I'd insert 2. 6 minus 2 is the square root of 4 plus 4. Square root of 4 is 2. 2 plus 4 is 6. Does 6 equal 2? Last time I checked, you were right. 6 does not equal 2. This is what we call an extraneous root. Everything we did made it appear like it should work. We did a whole bunch of math, and we got x equals 2 as an answer, but when we checked it, it did not work. So the only answer is x equals 5. Lots of stuff happening in one question, right? You have to, whenever we learn something new, we need to remember all of the things about it. So a radical equation. We've previously learned you can get rid of a radical by squaring both sides. You need to isolate that radical first in order for that to happen. And then we ended up with a quadratic equation, so it triggered the new stuff that we're learning. Quadratic equation. Have to use the zero product property to solve those. Set something equal to 0 and factor. Then, because the original one was a radical equation, we must verify. So we went through, solved it, and when we verified it, one of the answers didn't work. Circle question 12.